This is Purvi Thakkar. I am the OpenNESS product manager in the Edge segment team at Intel. And today I will be covering the topic of powering next generation networks and IoT applications on the OpenNESS platform with Actian Zen Database. So before I begin, I would like to thank Actian for giving Intel an opportunity for presenting in this virtual event of theirs. I would also like to acknowledge that Actian has been a valuable partner in embarking on this edge journey using OpenNESS by Intel. What are we going to cover today is essentially how easy it is to build and monetize edge services using OpenNESS by Intel, and we'll take Actian Zen Database as an example. So one more thing, please feel free to use the chat window as you get questions during the course of the presentation. I'll be monitoring it on a regular basis. So let's dive in. Let's set the stage by understanding the multi-access edge computing paradigm. This slide gives us a typical telco deployment landscape, starting from the on-premise edge, which is closer to the end-user devices or IoT devices, followed by the network edge, which is representative of the regional central offices or the next-generation central offices, followed by the central office, that is a network core, and finally the cloud data center. Imagine an application like Actian Database sitting in the cloud data center and an end user like you sitting in your home firing a SQL or a non-SQL query to the Actian database. This query undergoes multiple hops before it hits the cloud, and the query gets processed and gets returned back. So it starts with your residence, which is the router device, which is the customer premise equipment device on the on-premise, which connects to the regional office of telco, followed by the network core, and then finally the cloud data center, where the processing happens and it goes back. This whole round trip takes roughly around 100 milliseconds. It is okay for generic applications and most of the applications in the data center space. But consider the example of a casino gaming application. The end user will get a jittery experience. So to avoid this, the casino gaming vendor moves the compute, that is the gaming logic, along with the database closer to the gamers in a casino gaming center where a local area network connects the various casino terminals with the servers and the database to form a confined space for processing the traffic. It uses the routing policies and traffic steering policies through DNS to ensure that the traffic does not leave the casino gaming center, to ensure that the round trip reduces from 100 milliseconds to 1 to 5 milliseconds, thereby giving the casino gamer a rich end user experience. This bump in the wire approach is called edge computing, where the compute moves closer to the end user devices or the end users in particular. Now, if you extend this example of casino gaming to, say, AR/VR gaming application like Pokemon Go, where the end users are distributed across states and cities, then the Pokemon Go gaming vendor needs to start using the network edge infrastructure of the telcos, that is the regional central offices, to move the gaming logic closer to the end users by extending the infrastructure of the network edge. This bump in the wire approach, where the mobility protocols get kicked in, is called multi-access edge computing. So the simplest definition is edge computing with mobility protocols kicking in is called multi-access edge computing. And for the Pokemon Go gaming vendor, the latency gets reduced from 100 milliseconds to 10 to 40 milliseconds and gives the gamers a wonderful experience. This multi-access edge computing paradigm has opened a range of opportunities for the telcos and the various players across the value chain to build innovative edge services. There are newer business models and newer revenue streams that could be identified by provisioning these edge services, not only for the media and entertainment, that is the gaming space in particular, but more generically applying the same concept to industrial, transportation, smart cities, connected care, healthcare, and many more retail or other vertical specific use cases. It also opens the door for defining new KPIs or key performance indicators, as you can see on the left, like improve service capabilities, reducing the application latency to deliver richer user experiences. Some of the use cases also demand compliance with data locality or data sovereignty rules, in which case the data is conserved wherever it is instead of moving it across the network, thereby reducing the bandwidth consumption as well. And not to forget, when telco network edge infrastructure or on-premise infrastructure gets leveraged, the optimization of the total cost of ownership definitely happens. So these are the new KPIs that come in, and this opens up a new paradigm wherein new network access protocols like 4G, 5G, private LTE, CBRS all can be taken into consideration rather than just restricting it to local area network, Wi-Fi, or whatsoever. Now, what is multi-access edge computing platform? How does it look like? The center of the slide shows you that it is essentially a commercial off-the-shelf server based on Intel architecture, top it with operating system, add some resource and service orchestration software like Kubernetes, Red Hat OpenStack, OpenShift, or VMware vCloud NFV, then another layer of middleware on which the application layer is dependent on, and you can build powerful, innovative edge services. Though it looks simple, there are, of course, challenges to overcome to give you the deterministic, consistent performance to deliver the edge KPIs, because there is an interplay of many workloads. You have retail apps, you have orchestration apps, you have communication technology functions, the networking functions, which are coming in play. And so having those connect together and giving you the right edge KPI consistently is something that we all have to work together to build. Not to forget that the ecosystem is continuously growing. You have new innovative players coming in the market with AR, VR kind of applications and many more. And there is an industry standard body. In fact, there are many industry standard bodies which are working on growing the or making things easier for the various partners and customers across the value chain to build scalable architectures. Some of these bodies are ETSI, 3GPP, and many more. So ETSI, for example, stands for European Telecommunication Standard Institute. It has been instrumental in defining a multi-access edge computing reference architecture, and which is like equivalent to something that I just shared a few minutes ago. It's nothing but a hardware bomb with a bunch of services that make MEC services easy to build and provision. So let's get into more details of what are the kind of workloads that come into play when you build services at the edge. Edge is a very disruptive space. I told you before that there are going to be applications across verticals: retail, industrial, media and entertainment, agriculture, aerospace, military, defense, and many more, where time sensitivity is important for mission critical applications. But not to forget even the functions by horizontal, where you will definitely need the basic storage, networking, compute applications, not to forget the databases like Actian, the virtual network functions, the container network functions, which implement the 4G, 5G functionality, the AI, machine learning, inferencing apps, and the management and orchestration kind of apps. So Edge is driving workload convergence of information technology, operational technology, and communication technology workloads. To take care of these kind of workloads who are coming together, we have to have a foundation which adopts some of the data center best practices of elasticity, resiliency, scalability, and also high availability requirements. And seems like cloud native technologies can be a good foundation for building a multi-access edge computing platform. This introduces us to OpenNESS, Open Network Edge Services software. It is Intel's multi-access edge computing open source toolkit, which is built on the foundation of cloud native technologies. What is it all about? It helps to move your application, whether you have put the application on bare metal infrastructure or cloud infrastructure. You can seamlessly move it to the edge without being bothered about the underlying network complexity that comes with 4G, 5G, private LTE, CBRS, or Wi-Fi kind of protocols. The application vendor just needs to focus on the business logic associated with its app. The architecture of OpenNESS is so built that it is modular. It can be consumed as a whole or in individual building blocks. It is a microservices-based architecture which is based on Docker and Kubernetes and is CNCF certified. It takes care of all the KPIs that we were talking about earlier, all the workloads and the use cases. It makes life easy for you and is an enabler solution to get you a jump start on building and provisioning powerful edge services with your apps, and you can start monetizing at the edge. Let's take the example of how the building blocks can be leveraged. For example, let's take the accelerator building block that you see here in the center of the screen. An AI application typically would like to use that building block by using its AI model and porting it to Intel architecture, either a CPU or a accelerator ingredient, a vision accelerator, by optimizing its model using OpenVINO toolkit for underlying Intel architecture, and then running it on any of the vision accelerators or CPUs. So that gives you a quick start and you get a best known configuration which gives you deterministic performance to realize your edge KPIs. Similarly, there is another component called data plane CNIs, container networking interfaces, as you might have heard in the Kubernetes world. These actually create virtual network interfaces for the applications who sit as edge applications on an OpenNESS edge node, so as to steer the traffic through a bump in the wire approach from the underlying network protocol to meet those stringent edge KPIs. The telco world is quite different from the data center world in terms of the packets that need to be processed. There are tools and technologies like data plane development kit, which optimize the throughput of the packet performance, and also it helps create virtual network interfaces through technologies like OVN, OVS, DPDK, SRIOV, DPDK, and many more, through which you can start exporting those virtual network interfaces to the various applications, including the virtual network functions and the container network functions, which host the 4G, 5G logic for packet switching. So what else does it have? It includes, it is continuously evolving by taking inputs from industry standard groups, and and also builds upon the years of expertise that Intel has had through working with various communication service providers or the telcos. So you can think of some of the industry standard groups whom we are constantly taking inputs from are like 3GPP, CNCF, ORAN, ETSI, and many more as things get to newer standards. So that is what openness is in a nutshell. And let's top it with the top three value proposition points for it. So as I told you before, it is an enabler solution because of its ease of use and consumability. So it will accelerate your time to market for building and provisioning edge services. It gives you a network access protocol abstraction so that the app vendors can focus on the business logic rather than breaking their head on the underlying networking complexity. Also, it gives you a best known configuration which is hardened at the hardware, software, firmware level so as to deliver deterministic and consistent performance for realizing the edge KPIs. So that is what OpenNESS is. Now you must be thinking how it looks like. So in the basic form, you can think of OpenNESS being like a deployed in a 2-node edge cluster with the OpenNESS controller to the right and OpenNESS edge node to the left. Now, as I told you, it's all building blocks. So you will see the various building blocks like system pods, CNIs, the platform pods, which host the accelerator building blocks, and much more. So because of the real estate constraints of the slide, we could not include all the building blocks, but essentially it covers the significant ones. So your applications could reside in the application pods. You can imagine an Actian database sitting there, a CDN app or a smart city app sitting there, or a VNF CNF function sitting in the application pod. And you can also have a connector to the clouds, the public clouds like Amazon or Azure through these application pods. Now, how is the bump in the wire approach created? So if you look at the bottom left, you will see the E node B and the G node B components. They are representatives of 4G and 5G base stations, and they connect to the 4G 5G core. The 4G core is Evolved Packet Core or EPC, and 5G core is NGC, and each of these cores are modular enough to include different components. To create a breakout session or a bump in the wire, what we do is we tap into the user plane component of those cores. So for 5G, it is UPF, user plane forwarding component, and for 4G, it is packet gateway user plane, which is PGWU. And you can see the traffic going from the bottom to the data plane CNIs, which export the various virtual network interfaces to which the application pods connect, and the traffic gets steered to them when they register as edge applications through the OpenNESS controller. So you will also see that the steering logic is implemented by the system pods which host the multi-access edge computing logic. The DNS helps in steering the traffic to the right application pod. The rest of the traffic goes to the public cloud, as you can see at the bottom right. So this is how the breakout session is created, and you will have the OpenNESS controller containing the Kubernetes control plane components as well as various control plane components to manage the 4G, 5G networking aspects for the application layers so that they are totally abstracted away from the network complexity underlying. So that is what OpenNESS is all about. It's a very interesting platform for people to try out to start monetizing at the edge. So now we are in the Actian conference. We want to know what is the importance of data management at the edge. So data has been an essential commodity from time beginning of mankind. It has been like food, clothing, and shelter, and its relevance has become more and more important through powerful data management technologies like what Actian provides. So as the data management is important for any cloud or data center application, it is equally relevant for the edge, even so more because of the mission criticality of the applications. What kind of capabilities are expected? What kind of workloads are expected? The same workloads and KPIs which are relevant to the data center world are also relevant to the edge. You will have business intelligence to do at the edge. You will have massive data sets to process at the edge. You will have heavy transactional processing to be done at the edge, not to forget the data security. Then you will have AI, machine learning processing. You will have predictive analytics as well as real-time analytics. And the capabilities that are demanded from an edge platform are the same like the data center platform. In fact, even more performance is needed because of the time criticality of the applications involved. So you will need to deliver business value in extreme real time. You will have to do parallel processing on extremely larger data sets and also to cater to low latency requirements of mission critical transactions. So it goes without saying that the KPIs very well resonate with the edge workloads and the KPIs. So what does Intel offer in terms of portfolio of solutions to database vendors? Not just the database vendors, it also applies to applications in particular. So Intel has a rich portfolio of solutions across the data management pipeline, right from ingest to store to process to building meaningful insights out of the data. It has technologies like Intel Silicon Photonics, Intel Ethernet, and Tofino to move data faster. To store and access data faster, you have Intel Optane DC persistent memory and Intel Optane SSDs. And then, not to forget the compute power to process everything through CPU and accelerator product line. We know that data is essential for survival of organizations, but it's also important to stress that organizations that harness data, cloud, advanced analytics, and AI always outperform. I would like to touch a little bit on the Intel Optane DC persistent memory product line. So These graphs are indicative of some stats from the market. We know with the data explosion, the compute demand increased, and the market has been able to successfully capture the compute demand with its supply across different product lines. But there has been a growing demand even for the memory. However, for some reason, the DRAM has not scaled enough, which has led to a gap in the demand and the supply. And that is where Intel got in through its Intel Optane DC persistent memory product line. You can see the various tiers from hot to cold tier. The Optane DC persistent memory sits just below the DRAM. It comes in 100 gigs of capacity and with a latency of less than 1 microsecond. You can use the Optane DC persistent memory for in-memory database processing or as a caching tier. And then as data gets older, you can retire it to Optane SSDs and then finally to the cold storage NAND SSDs, and finally for archiving in HDD or tape drives. So value proposition in top 3 points, it definitely comes with a lot of performance power, so you can extract more from larger data sets. It is priced at a price point which gives you the cost performance trade-off when compared to RAM and storage. So you can get a good total cost of ownership KPI value for when you consider the various workloads that it can manage. Not to forget the inbuilt protection or the encryption abilities that it brings in, which helps you protect data automatically. So now let's understand what we did together, Actian and Intel, how they are positioning itself together for the edge. You all know Actian better than I do. It comes with a range of solutions starting from Zen Core to Edge to Enterprise to Zen Cloud. Since we were focused on the Edge, we picked up the Zen Edge and the Zen Core and positioned it with OpenNESS. OpenNESS can be sitting on the Edge gateway for providing the multi-access edge computing functionality, along with Actian Zen Database for applications or IoT devices to connect with it and send data to it and process data using SQL, NoSQL, and analytics kind of queries. So that is how we are jointly positioning. We know the database has its wonderful features. It comes in nano footprint it has a very small nano footprint consumption on the device. It can sit in a Raspberry Pi device. It can also it can process lots of uh, data formats like JSON or blobs. It comes with support for various operating systems. It also comes with support for various programming languages, and it is modular and scalable. So certainly a recommended database, especially since it is optimized for openness, a recommended database for the edge. So what we did together was after we spoke to Actian, we invited them to join our program called Commercial Applications for the Edge, where any application who wishes to monetize at the edge can come and speak to us. This is an open invitation to all of Actian partners and customers who wish to embark on the edge journey. We can really get you started. You just have to click the How to Participate button on this website, and a mail gets sent to us, and we connect our folks to you. The program is very well defined. We'll talk more about it. It's like the portal by itself is a pseudo co-selling portal. It connects the customers who have openness or smart edge in their infrastructure with the various partners who are on the portal and optimized for openness or smart edge. So openness is as you know, we just spoke about it, is an open source MEC offering from Intel. Smart Edge is a commercial MEC offering from Intel. So whichever product you choose for optimizing with and embarking on the edge journey, you can join the Commercial Edge Applications program. The program is very systematically organized. It starts with a strategic enablement phase where we speak to the partner to understand their application and its relevance to the edge. And we also educate the partner about what the program is and what are the benefits associated with it. Once there is a mutual agreement, we move the partner to the technical enablement phase. In the technical enablement phase, we uh, we make the partner package its containerized application or a VM-based application in the form of Helm charts, which is a Kubernetes package management utility, and onboard the application, which is packaged as Helm charts, onto an OpenNESS or a Smart Edge cluster and test for its application KPIs. Once you have tested, you are technically enabled for OpenNESS or Smart Edge. For OpenNESS, we expect that you check in the Helm charts in the OpenNESS GitHub project in the Edge Apps repository. The binary can stay wherever you want to keep it. It is your IP. Our engineering team reviews the Helm charts against the contribution guidelines and gives you a green to check in into the OpenNESS Edge Apps repo. So the binary could stay in a public-private Docker registry or a FTP site, and the customer, when reaches out to you, you can work with them to define the business or process model with which you want to work with them, do the licensing agreements, and many other aspects. We don't come in the way, we just connect the dots between the partners and the customers. So after the technical enablement phase is done, we prep you up for documenting on the commercial apps portal. So each logo is clickable into a partner specific microsite where we document the how to do and the where to buy steps. The how to do steps document the configuration, installation, uninstallation kind of steps, and the where to buy give the customers a quick start to reach out to you for any additional questions that they may have or to purchase your product. So your microsite is also like a pseudo co-selling portal. It is a one-stop shop for customers to reach out to you and understand your product at the technical level. Now, the commercial edge applications portal is so designed that when the customers who have OpenNESS or Smart Edge in their edge infrastructure come to it to figure out how to build powerful edge services across verticals, they filter on the web portal by tags or search filters which are based on verticals like retail, industrial, or workloads or use cases like AI or machine learning, or they may search for horizontal functions like database, and based on that, the shortlisted partners show up. And then they can go and look at each of the microsites to figure out which ones they like and reach out to you directly through the documentation on the microsite. So it is as simple as that. A partner, when interested in this, can finish the whole process within a one with a focused effort of 1 month, depending upon the simplicity of the optimization that you want to do. So it is pretty simple. And to get you started, we also have some quick links here. And that is all that I wanted to cover today. So an open invitation once again to everybody to join us in this edge journey. You are already integrated with Actian. Your half the battle is won. Now you have to optimize for openness, and we can rock and roll together and monetize at the edge. So that's all that I wanted to cover today. Thank you for your time and patience. I'll be available offline for any questions that you might have. Thank you so much.